This video showcases another example of bisection method on a different curve configuration. Welcome to Numerical Solutions to CE Problems. The problem requires the positive root nearest the origin, accurate in 3 decimal places, for f of x is equal to x cubed minus 3 of x squared plus 1. Again, we start with finding the initial values through assumption. First, we assume x to be 0. F of x becomes 0 cubed minus thrice of 0 squared plus 1 as 1. If x is 1, f of 1 becomes 1 cubed minus 3 times 1 squared plus 1, which results to negative 1. Illustrate the coordinates and get the lower limit as x equal to 0, and the curve is at y equal to 1. For the upper limit, at x equal to 1, y comes as negative 1. So connecting these 2 points, the curve goes downwards. Now, we take half of the interval at c. That would be at x equal to 0.5. The f of 0.5 is solved as 0.5 cubed minus 3 times 0.5 squared plus 1, giving 0.375. With f of c already figured out, we have established iteration 1. Next is to identify which should be replaced by c. So take a look at the sign of f of c, which in this case is positive. This entails that c should replace the positive initial limit, which is a. So f of a for the second iteration is 0.375. b and f of b remain the same, so they are just copied down the second iteration. So with these parameters placed, we can now solve c as 0.5 plus 1 over 2, giving 0.75. Then use this value to figure out f of c, which comes out as negative 0.2656. Take note that this is with a negative sign, which means c should replace b. Moving on to the next iteration, b is then 0.75 with f of b as negative 0.2656. Then a remains the same as 0.5 with f of a as 0.375. With the first 4 columns already filled, we can compute c as 0.5 plus 0.75 divided by 2, resulting to 0.625. Use this to look for f of 0.625, which yields 0.0723. Having this last value as positive, c should replace a. Iteration 4 has a as 0.625, f of a as 0.0723, then b of 0.75, with f of b as negative 0.2656. c is then taken as 0.625 plus 0.75 over 2 to get 0.6875. Now take f of c as 0.6875 cubed minus 3 times 0.6875 squared plus 1 to get negative 0.093. With this value coming as negative, C is then used as B on the next iteration. The iteration still runs the same. B is 0.6875 and f of B is negative 0.093. A is still 0.625 and f of A is 0.0723. C is taken as 0.625 plus 0.6875 over 2 to have 0.6562. F of C is then computed as negative 0.0094. With this coming as negative, we are to replace B. Iteration 6 then has B as 0.6562, with f of B as negative 0.0094. A remains as 0.625 and f of A as 0.0723. C is then computed as 0.625 plus 0.6562 over 2 to get 0.6406. And f of 0.6406 comes as 0.0317. This is positive, so C should replace A. For this next iteration, we use the updated A as 0.6406, with f of A as 0.0317. B is still 0.6562, with f of B as negative 0.0094. With A and B already determined, C is computed as 0.6406 plus 0.6562 over 2 to have C as 0.6484. F of C as this value becomes 0.0112. With f of C as positive, we replace A in the next iteration. So A becomes 0.6484 and f of A is 0.0112. B is still 0.6562 with f of B as negative 0.0094. C is then 0.6484 plus 0.6562 divided by 2 to have 0.6523. Use this to have f of C, which becomes 0.0009. Since this is positive, C should replace A. For iteration 9, A is 0.6523 and f of A is 0.0009. B is 0.6562 with f of B as negative 0.0094. So C is computed as 0.6523 plus 0.6562 over 2 to get 0.6543. Plug this into the equation to get f of C as negative 0.0042. Negative for our f of C would mean that we should replace B. Continue with the iteration with B as 0.6543 and f of B as negative 0.0042. A is 0.6523 with f of A as 0.0009. C at this point is taken as 0.6533 with f of C computed as negative 0.0016. Again, f of C turns out as negative, so C replaces B. The 11th iteration has B as 0.6533 with f of B as negative 0.0016. A remains at 0.6523 with f of A as 0.0009. C is then taken as 0.6523 plus 0.6533 over 2 to get 0.6528. Place this value to f of C and get negative 0.0003. With f of C reaching the accuracy required, we take the x-intercept as 0.6528.